now. Tommy, go ahead.
Okay, good morning, everyone. Just give me a second here.
Mr. Kelly, you're welcome.
Okay. Can everyone see my screen?
Yeah, okay.
Yes.
Okay, perfect. Good morning, everyone. And thank you, Mr. Prince, for the introduction. Like you said, my name is Tommy. You can call me Full Hours or Tommy, whatever works. And we're going to be going over Terraform today, basically everything you need to know about Terraform. It's basically like an infrastructure as code tool. And the agenda today is we're going to go over what is Terraform, infrastructure as code, the meaning of infrastructure as code, phases of Terraform, the main components of Terraform configuration, and then you have different features within Terraform that you can utilize, which is called the provisioner connection settings. And then you have difference between imperative and declarative. We're also going to go over the comparisons between Terraform and other tools like Ansible and Puppet. And then I'll open the floor for Q&A in case if anyone has any questions. However, if anyone has any questions before we get to Q&A, feel free to stop me or just cut me off. And then we do have the hands-on exercise. It's going to be installing Terraform on your local machine. And the other would be deploying EC2 server with Terraform. So we do have a lot going on today, but I promise it's going to be fun. Sounds good?
Can you go, bros?
Sounds good.
Perfect. Okay, so this is basically a simple infrastructure. Majority of the enterprise or real life settings, they use Terraform for their provisioning just to create the infrastructure. And a lot of enterprises also uses Jenkins. Jenkins is where you set up your CI/CD pipeline. So think of Jenkins like your orchestration tool, right? And then you can integrate Terraform with Jenkins to provision whatever server or infrastructure you need. And of course, the cloud provider is talking to is Amazon in this case, because we're using Amazon. We're not using any other cloud providers. However, Terraform does support third-party providers. And I'm going to go into in depth other providers they support later on in this session. Okay, let's go to the next slide. So the prerequisites, you need an AWS account. I believe you guys already have this. Of course, you have to have VS Code downloaded on your computer. I believe you guys already have this as well. And then download Terraform on your computer. I know you guys didn't get the link to this, but we'll be going over this. This is very, very simple. It should just take a minute or so. And guys, if I'm going too fast, feel free to cut me off too as well. Okay, moving along. The fun stuff. Okay, so what is Terraform? Terraform is basically like an open source tool that is used for automation and managing your infrastructure, as well as platform and services as well. So this means any components within AWS Cloud, Terraform can be used to automate that process or the creation of that resource, right? Terraform is an open source tool, which means it's free. And it also has an enterprise version. The enterprise version is paid for. The difference between the enterprise version and the Terraform version is The open source, of course, it's a free version, so you're just allowed to create your infrastructure and then your state file, which I'll be going into. I don't want to go into that now, but I'll be going into that later on as well. But the enterprise version has more features that you can utilize to maximize security within your environment. So things like that, what you can, consider in case if it suits your business need. It just really depends on your organization. But the other open source tools like Jenkins, you can always integrate Terraform with to also maximize your security. It's just all about knowing how to integrate those tools together, essentially. So moving to benefits, the benefits of Terraform, like I mentioned before, it supports third-party services like AWS, Azure, or Google Cloud platforms. I believe it also supports OpenShift, if I'm not mistaken. Terraform is a declarative tool. So what that means is it defines the end results. So you have Ansible. I believe you guys have already gone through Ansible. But Ansible is like, within an Ansible is a playbook, right? And within a playbook, you have a set of tasks where you have to tell Ansible, run this, run this, run this. That is imperative because it has a set of tasks that would need to be executed on the server. However, Terraform uses resources to manage the infrastructure, which is why it's declarative, because you don't need to define every step of what you want it to do on the server. It's just usually managed within a resource block, which I'll be showing you guys as well later on. The next benefit is it manages the existing infrastructure. So whenever you have provisioned, let's say for instance, EC2 server, and you need to make any modifications to that EC2 server, right? Let's say you need to update the AMI, or you need to update the security group. Within the Terraform, the reason why Terraform is so easy, and I personally prefer it to other tools, is because all you have to do is just basically make changes to that resource block, right? So it manages the existing infrastructure within the state file, which we would be going over as well, and is efficient. Terraform is efficient because you can keep it consistent between different life cycles. And what I mean by life cycles is you have your dev environment, you have your QA environment, you have your UAT environment, you have your prod environment. So of course, as a DevOps engineer, if you're working with like a developer or whatever the case might be, you need to test in lower life cycles before pushing to prod, right? Whatever application you're working on. So Terraform allows you to be efficient and consistent within those automated processes. Okay, so infrastructure as code. What is infrastructure as code? Infrastructure as code is basically a setup that allows you to run an application which consists of multiple resources. These resources are components of AWS. So when I say resources, I mean like things like your VPCs, your instances, like EC2 instance, your load balancer, your auto-scaling group, S3 bucket, anything you're required to provision for an application, that is your resource. Okay, so infrastructure as code is basically those resources running behind that application. And that's where Terraform comes in. Rather than you having to go to AWS and manually creating everything, you can use Terraform to automate the process within a couple of minutes, right? So that's the whole point of being a DevOps engineer, DevOps engineers to detect code, also allow all the environments to be efficient, like I said, consistent, detect bugs, and the best way of doing that is implementing tools like Terraform, right? So as you can see here, you have a EC2 instance, which is behind a load balancer. So this load balancer here is basically is redirecting traffic to the internet, right? So this is within your VPC, which is your network. And then your this two EC2 instance is just behind this load balancer redirecting traffic to the web, to the users. So Terraform basically automated this whole process, the VPC, the creation of the VPC, the load balancer, and the EC2 instance. That's pretty much it. So that's pretty much the gist of infrastructure as code. There's really nothing too complex of Terraform. And now we can move to the phases of Terraform. It's broken into 4 different segments. The first one is the code. Of course, this is the configuration file. This contains the resources that I mentioned earlier and set of arguments that supports that, right? And then the next one, you have the Terraform init. This is a Terraform CLI command that you can leverage to run Terraform commands to initialize and download the necessary plugins that are needed to make API calls to whatever provider you're talking to. So API calls, what I mean by API calls is, of course, before you can talk to anything, you need to provide some kind of credentials, right? Whether it be an access key or a secret key. So in this case, for Terraform to be able to talk to any provider or, any provider like AWS, Azure, Google, you need those credentials. And that would be the secret key and the access key. So whenever you supply those credentials, what it's going to do whenever you run the command is it's going to download AWS, the plugins for AWS and whatever resources that are needed to run or execute the job. Okay, so that's what Terraform init does. And then you have Terraform plan. Terraform plan is another CLI command. This is used to basically give you a rundown of what you're about to provision. So it's going to give you like an output, right? Before you execute it, it's going to give you an output of what is about to be executed. And also, one thing about Terraform plan as well is whenever you've provisioned an infrastructure for the first time.
Excuse me.
Can you mute yourself, please?
Please, do you mind mute them, please? Thank you. Okay, so one thing about Terraform plan as well is it compares the desired state to the one that actually exists. So what that means is whenever you have provisioned your first infrastructure, or let's say, to make this simple, you've created your first EC2 instance with Terraform, right? That state file exists. The state file basically is a blueprint of what you just created, right? It's gonna have all the metadata, right? So now if you increase the count of the EC2 instance from 1 to 2, it's gonna know and automatically compare the new existing change to what exists in the state file and make that changes, right? So that's what plan does. It's just gonna show you what changes are gonna make, and it's gonna output it for you, right? And then lastly, of course, you have the Terraform apply. Terraform apply is where it leverages the cloud provider APIs and creates the infrastructure, basically. And this also outputs the variables along the way. This depends if you define the arguments within your configuration code, right? So those are the 4 phases that you really need to know about. Once again, the code is the configuration file. Terraform init is where you download the necessary plugins to talk to the API, to talk to the provider. Terraform plan is also another CLI command that you can use to show you the output of what you're about to execute, and also compares the desired to the one that actually exists. Apply is where you just execute basically you execute whatever changes or configuration you have and spin them up, leveraging the cloud API. Okay.
Question.
Any questions over that?
Yeah, I have a
go ahead.
question. So regardless of whichever process, either code, plan, init, or apply, you still need some type of code from the other provider, in this case, AWS, that you intend to interact with, correct?
Correct. So I'm going to be showing you that probably in the next 2 slides, how you can connect to AWS Cloud, but you're going to need some kind of credentials, which we'll be going over shortly.
Correct, but regardless of whether if you're trying to connect via init, apply, or plan or code, you still need some type of credential, is my question.
Yes, correct.
If I remember, Terraform is a third party kind of situation, so yes.
Okay.
Hello.
Yeah.
Like from the last person's question, I don't understand. Is code a way to connect, plan a way to connect, init a way to connect, apply a way to connect? Because I don't understand what he is.
Okay,
How many
so-
ways can you use to connect? Because okay.
To connect, you just need your credentials, right? All this is just phases of Terraform. Like this is just code. This is just an AWS command that you're going to use to initialize Terraform to work with whatever cloud provider you're talking to after you've supplied the credential.
Okay.
So
So
does
that
that
means
make sense?
okay, yeah. That means you can use like okay, let me give an example so I can understand it clearly. Like using a mobile extend to connect or using Git, right? That's what I'm saying.
So that's a little bit different. So let's look at a Terraform code, for instance. I'm just gonna skip. So this is a provider, right? We're talking to AWS in this case. We need an access key, we need a secret key, and we need the region we're gonna be talking to, right? Here we're provisioning an EC2 instance. So this resource, this is not something I had to write. This is a template that already exists. So this is why I said Terraform already has those resources template that are available to you on the web. The only thing you need to make usually whenever you're writing Terraform is just a little bit of modification to suit whatever need of the application, right? But in this case, I'm just provisioning an EC2 instance. Here, I've already supplied the credential. This is the resource that I need to create the EC2 instance. To create an EC2 instance, of course, you just need the AMI and instance type, which is right here, and the T2 macro. This, you can name it whatever. This is the name of the resource, which is AWS_instance. This is the local name that you can give it. You can give it whatever you want. So I can call this EC2 instance or whatever I want. So now to be able to run this configuration file, I have to, now I've already performed this first step, which is the configuration file, right? Now the second step would be Terraform init. Terraform init is where it's gonna download all the necessary plugins I need for AWS to talk to AWS, right? Once I run Terraform init in my terminal, so that just downloads the plugins. It doesn't do anything apart from downloading the plugins. After that, the next step would be Terraform plan. You run this command, and it's gonna give you an output of what you're about to do, right? So it's gonna show you that, okay, I'm creating one EC2 instance. There are no changes, and there's nothing else to be destroyed. I'm just creating one EC2 instance. That's gonna give you the output on your terminal. And then lastly, you're gonna run the Terraform apply. This is gonna take that configuration file, and it's gonna apply the change and create the EC2 instance in AWS. Does that make sense?
This
Yes.
is Serge. Yeah, quick question. So how do you know the plugin that you need to download? Is it done automatically, or you just have to figure it out?
So it's done automatically. This is whenever you run Terraform init, based on the configuration you supply, based on whatever provider you supply in your configuration file, whenever you run Terraform init, it's automatically going to download all the necessary plugins you need to talk to AWS. So let's say, for an example, this is not AWS. Let's say you're working in a different environment that is an Azure environment. That is a different cloud environment, right? This would be Azure. This here that shows AWS would be Azure. And then you supply the access key and the secret key to talk to Azure. So whenever you run Terraform init, it's going to download the plugin to talk to Azure, not AWS.
Okay, thanks.
Answers your question?
Yeah, you did. Thanks.
Cool.
Can I ask you a question? This is Femi.
Yeah, go ahead.
From the output on the screen, I see where a provider AWS is called. Is that like a module?
No, so this is just a provider. There are also modules in Terraform. Modules is completely different. Modules is where you can call a different configuration, right? So let's say, I really don't want to dive into that, but I'll just give you like a synopsis of how it works. Let's say I have this configuration in a folder, right? And then I have this configuration in another folder, just a new file. And then I'm trying to call a different configuration from, let's say, this is defined as AWS. And then I name this Tomcat server. And then I have a different folder that has Artifactory server. But I want to call that Artifactory server in this configuration file, in this block. All I have to do is just specify that module here, which would have the defined parameters, right? And then I can just run whatever configuration I have from the current directory without going to that other directory to run the resources, if that makes sense.
That makes sense. And lastly, the place where access key and secret key is it advisable in the workplace scenario that you use the access key and secret key?
No, it's not. This is just for example purposes, just to get you guys familiar with Terraform. That's actually a very good question. So we're going to be going over tomorrow how we can basically hide these credentials and basically maximize like security to make sure we're not exposing anything on our EC2 instance or anything like that. But we'll be going over that on how we can basically encode this in Jenkins. Sound good?
Thank you very much.
Yes, sir. This is
Another
Niven.
question.
Oh, go ahead.
This is Dami. So on this state file, right?
This is the
Can we-
config file.
Config file. Okay. So on this config file, so say we've already provisioned an instance and say we want to change the instance size, say from T2 macro to like T2 medium or T2 large. Can we come in and make that and just edit the instance type, and it will automatically do that for us, or we have to provision another server of that instance type?
Another great question. So if you need to change the instance type after, are you saying after it's already been created?
Yes. After it's already been created. Yeah.
Okay. Yeah. So after it's been created, if you want to make changes, you just modify your configuration file, which is this line 9. Change it to whatever instance type you want, and then you're going to run those commands that I mentioned: the Terraform, init Terraform plan, and Terraform apply. Once you run the Terraform apply, it's automatically going to update the Terraform instance type to the new new one.
Okay. Thank you.
Yes, sir.
Any other questions?
Yes, sir. I have a question. So the credentials that you have there, like the secret key and the access key, is that provided for you, or is that something that you have to code by yourself?
That is something that is going to be that has to be generated from AWS. I'll also be showing you on how to do that the secure way and how to do that for testing purposes. We're going to be going over that too as well later on.
Okay, thank you.
No worries. Any other questions before we move along?
No, I think we can move on now. Thank you.
Okay. Great question, guys. So let's go over the architecture of Terraform. So Terraform is basically broken into 2 main components. The main components are Terraform core, and then you have the provisioners and provider. That is basically like grouped into one, okay? So the Terraform core is where it has the Terraform configuration file itself. And then it also has the state file, which I mentioned. The state file is like a blueprint, right, of what you've just created. It basically has all the metadata in that file. So this is what allows you to track your changes. If you need to destroy that infrastructure, is this the thing that Terraform depends on is the state file. If you don't have that state file, let's say for instance you lose your state file, right, or you delete your state file accident, and you already have an infrastructure that already exists in AWS, you won't be able to delete those resources with Terraform. You have to manually delete it because the state file is already misplaced or deleted. So always note that the state file is what Terraform relies on to do the changes required. Also, the providers are where you can just talk to different clouds like Amazon, Azure, Google cloud provider. Provisioners are a little bit different. This is actually pretty interesting. The provisioners are where you can leverage it because they're different kind of provisioners. You have the file provisioners, you have the remote exec provisioners, and then you also have the local exec provisioners, right? But we're gonna go over that shortly. And then this is where it basically makes the API calls. So with that credential you provide, it's just gonna make the API call through HTTP or HTTPS to the API of the cloud, and then create the resources that you need. And then we already ran over the configuration file. As you can see, the provider, this is the provider, excuse me. This is the provider's block here. The access key and the secret key is required for this to work, as well as the region. For the AWS instance resource, this is something you can see on the internet. It's not something you write. Like I said, a lot of this resources and this resources block already out there on the internet. Like I say, you just need to make a little bit of modification to suit whatever needs. So yeah, this is the configuration file, and you just need to supply the EMI and the instance type, which is required to create the EC2 instance. So like I said, I'm going to be going over the provisioners. You have a provisioner connection setting. What most provisioners require, like access to remote resource. So think of a provisioner as, let's say for instance, I'm going to go over this first one, the file provisioner. You want to copy a file from your local machine, your computer, to the server that you're creating. You can utilize this provisioner file to do that, but you have to also make sure you have the connection settings within this AWS instance. And I'll be showing you an example of that here. So if you see here, this copies the local files from my computer to the remote server that I'm creating. This is gonna be, this block is gonna be within your AWS instance block, by the way. So whatever block you're using to create your EC2 instance, this has to be present in there. So here is the provisioner file. The source is where I have my shell script, which is in my local computer, my local machine. And then the destination is where I want it to go on the server. So I want it to go to the home/EC2/user directory on the server. So this is a good way of copying whatever files you need to the server. And then you can always like bootstrap it too as well, like run that shell script to install your application as needed. The connections string here, this is where it's allowed to use SSH to talk to the remote server you're provisioning. So in this case, I have to provide what type of OS platform I'm connecting to, right? If it's a Linux, of course, it has to be SSH. If it's a Windows, then of course, it's gonna be WinRM. I'm not really familiar with Windows. I'm a Linux guy, so please don't ask me about Windows. But yeah, so you just, if it's a Linux, like I said, it's gonna be through SSH, and then if it's Windows, it's gonna be through WinRM. And then the user, you're gonna be supplying the user here. So if you're provisioning an Ubuntu server, of course, this is gonna be Ubuntu. If it's a Linux server, then of course it's gonna be the default, I believe, for Amazon Linux servers are EC2-users. And then if it's for a CentOS server, it's gonna be CentOS. So whatever platform you're creating, just make sure this corresponds to that. Line 10, the host, this would be the host of whatever you're provisioning. So I'll show you how to reference this. This one, I'm gonna be covering this today, but I just wanna show you how to use it. Tomorrow, we're gonna be covering this. So you're just gonna reference the host here, and then the private key. This would be your private key that you're gonna utilize to connect that box. And then you have the timeout time frame. This is, I usually like to set this because I don't like my Terraform running for a long time. I don't like waiting for a long time. So if I'm having issues with the connection string to copy any file from my local machine to the server, I want it to time out within 2 minutes. So that way I can just go in there and debug what the issue is instead of me having to wait for a long time. So that's why I set timeout to 2 minutes here. So that's how the provisioner file works. Any questions on this? Okay. Silence usually means golden, so we can move along. So the next one is the remote exec. The remote exec is also another good way of basically doing configuration. You remember I said Terraform is not a configuration management tool. Terraform is more like a tool for provisioning and basically managing your infrastructure. That is two different things. Ansible is more like a configuration management tool that allows you to update packages, things like that. But Ansible can't do, Terraform can't do that. It doesn't have the capacity to do that, right? But there are ways you can also play like cat and mouse and kind of like work around it. And I'll show you how. So with the remote exec, you can use the remote exec to evoke like scripts on your remote resource. So the remote resource is the server you're provisioning after it has been created. This can be used to run a configuration management tool, bootstrap into a cluster. So I know you guys just went over EKS cluster last week. So this is a way you can also bootstrap whatever configuration you want into that clusters. Kubernetes is a little bit different. And it's a little bit more complex to provision on Terraform because you need to understand the different parts of Kubernetes. But this is a good way to basically bootstrap whatever configuration you want into a cluster or a server. As you can see here, the remote exec also supports SSH, WinRM type of connections. So this is for Windows and this is for Linux-based platforms. And then you just basically list the commands you want it to do. So in this case, I'm installing AWS CLI on the server. And then this is just echo. Then I'm just giving this file executable rights. So that way it's executable, right? And then I'm just telling it to echo the date. And then after, just run that shell script. And this is gonna print the current directory that I'm working from. Okay, so whenever you're configuring this, just bear in mind that you're gonna also need this connection settings. So both the file on the remote exec, these two provisioners needs the connection string to be able to perform those actions, right? So for Terraform to be able to copy a file that exists in your local machine to the server, make sure the connection setting is defined, as well as if you want to run any configuration through remote exec on the server, make sure you also have your connection settings that exist present. The last one on the list is the local exec.
Sorry to cut you off. I have a question.
Yeah, go ahead.
So this is Dami. So for the provisioners, for these codes, you have to write it yourself. So I'm just saying this for on behalf of a lot of people that doesn't really have a deep understanding of Linux or how to write all these things. You have to write this, or it will be given to you, or you have a kind of a repository where you can copy all these things and just put in there, specify whatever you want the provisioners to do for you.
Great question. That's actually a really, really great question. So let me give you an overview so you can get more context, right? There are different kinds of DevOps is so broad, right? You have the cloud engineers, you have the middleware space where you guys have to basically find solutions. So let's say you're working in an enterprise, right? And you're hired as a DevOps engineer or whatever, and that team is working in a middleware team. What middleware team does is they find solutions out there that are open source. So if your company is currently paying for Terraform, the enterprise version, and that is costing your enterprise a lot of money, you're looking for ways to save the enterprise money, right? And save costs. This is where you come in. You recommend Terraform open source. We can utilize those tools. Okay, how can we make sure it also meets security standard? That's where you implement it with things like Jenkins and make sure the credentials are secured and things like that. Now you have the cloud engineer. The cloud engineer is where they work in the operation side of things, which is the AWS. Anytime a server goes down, they troubleshoot. Their job is usually just to automate the processes of an application, right? Or push out new releases. If that is the job, if that's what you're hired for, the remote exec, right? This part here, the developer will supply that to you. They will supply you on how they would need to trigger the installation of the application, because obviously you're not a developer, right? You don't know anything about how the application runs. Your job is just to come up with an automated process on making their configuration and whatever deployment they need to do seamless. And that's where you're using infrastructure as called Terraform. So that's what you do as a cloud engineer. In the middleware space, you will have to set up the whole thing. So this means they would have and this would relate to the project you're about to do next week, because you're gonna have a WAR file, right? A WAR file of an application where you have to set up a CI pipeline. The CI pipeline is going to consist of, your checkout, your Maven, where it compiles your code. You run your code for vulnerabilities, and then you push it to Artifactory, right? What you're pushing to Artifactory is the WAR file you just received online. So that can be an application, right? So this part here, the remote exec, you would need to run those Linux commands. And those Linux commands is not anything complex. It's just more of like, okay, tell me how or where that WAR file exists. How do I install that WAR file, if that makes sense? So majority of the time, to answer your question, you wouldn't have to configure whatever application. It just really depends on the environment you're working on. If you're working in the operations side of things, you would only mostly deal with automated things like writing the configuration of Terraform and then working with a developer to get their application deployable with Terraform. Make sense?
Yeah. I think I got it now. So if I get you in summary, this actually is more of a developer's job to do.
This is a developer's job as well as a DevOps job. So like I said, there are different spaces. They can tell you to find an application that is free, which is an open source. And they can tell you to go ahead and deploy that application within the enterprise, right? So you have to look for tools that would make the deployment seamless. So I'll give you an example. let's say they tell you to go deploy Jenkins. You wouldn't want to start deploying Jenkins from scratch manually, like clicking on AWS or create EC2 instance, then going on the server, logging into the server, and start having to configure Jenkins. That is too much work. And that is a lot of, that is going to require a lot of resource. That's where a DevOps engineer comes in. Your job is to automate everything, the CI/CD pipeline. Those are part of like best practices, right? So the remote exec here, this block already exists on the internet. The only thing you would need to change is the inline code. So this is right here, within right here. If you're familiar with Linux basic commands, you would realize that this is not really anything major. This is just something to configure the machine. But once again, you won't always have to do this. It just really depends on the environment you work in.
Okay, thank you so much.
No worries. Any other
Let
questions?
me add something to that. Remember your lab 0 to 3 or so, where they said, okay, install Java, install Maven, install, and the first thing we did was we spin up an instance, and then inside it, we now started installing Java, Maven, all those commands you have there, okay? With Terraform, you don't have to manually do all those things. You can have it within the Terraform scripts, all those commands within your Terraform remote exec block. Okay, once you put those commands there, as Terraform is spinning up those instances, it is doing that configuration for you, those installations, so that when the instance comes up, boom, you already see Jenkins, you already see Tomcat, SonarQube, all those things are already there for you. Does that make sense, guys?
That makes sense. Thank you, Prince.
That makes sense now. It does make sense now.
Perfect. Thank you, Mr. Prince. Okay, so moving along, the last one we have on the list is the provisional local exec. So this one doesn't require the connection settings. This is also another way of invoking anything you want to be ran, locally on your local machine or wherever you're running Terraform from. So Terraform, for this first example, we're going to be running Terraform from my local machine, of course, but Terraform can also be ran from a remote resource. So like a server, you can install Terraform on your Jenkins server, right? So that way your Jenkins is running your Terraform. So that's how you integrate Terraform with Jenkins. So if you're using this provisioner local exec, whenever you're running Terraform on your local machine, with this command here, it's going to echo your public IP into this text file locally. So this only happens on where you're running Terraform from. Okay, so if you're running it locally, it's going to output this public IP into this text file. And if you're running this on Jenkins, it's going to output this public IP to this text file on Jenkins. Okay, so that's what basically the local exec does. So just to give you like a run through, the provisional file copies the file from your local machine to the server. And you also have to make sure the connection setting is present for you to utilize this provisioning, this type of provisioner. The next one is the remote exec. The remote exec is where you can invoke a script within a remote resource. So this is basically configuring your instance while it's being created. But also the connection setting has to be present and defined for you to utilize this provisioner. Lastly, you have the local exec. The local exec doesn't need the connection settings. This is only used whenever you're trying to
Sorry, Tommy,
execute a
sorry to cut in. Where does the user data come in? Where all this?
the user data. The user data is another. It's another type of configuration. I forgot to actually add that in here, but I'll go over that too as well.
Oh, okay. Okay, that's fine. Because I'm thinking the user data can help you actually do some of the stuff that your remote exec can
Yes.
do. So it's kind of confusing somehow. Or is it the same, or is it a different way?
Yeah, so the remote exec is the configuration part, where you can execute the commands on the server, and then user data too is the same thing. So you can use either or. The only difference is remote exec shows you while you're executing whatever commands, whatever Linux commands within the remote exec, it shows you the output. If you're doing it on a user data, it doesn't show you. You have to log into that server to see what it's doing. Okay, and I'm just gonna show here. I don't have that here included in my notes, so tomorrow we'll go over user data. Yeah, we'll go over user data tomorrow because I don't have that included in my notes here. But essentially, it's the same thing as a remote exec. It just basically has the configuration. Instead of putting the configuration within a block, it just says user data and then defines whatever shell script it's going to call. And then you have to log into the server basically to see and follow the progress of whatever that script is doing, rather than the remote exec where it shows you the output whenever you're running it. Okay. So the local exec, like I said, it just basically executes whatever command you have locally or on the resource you're running Terraform on. So any questions there?
No questions.
Okay, cool. Okay, so moving to imperative and declarative. So imperative, like I said, is how to make the changes. So this is like a list of tasks, like Ansible. So you have like a list of what you wanted to do on the server. And this usually leverages like the API to do that. Terraform is quite different. Terraform uses the declarative approach, which leverages the resource to use the API to make, it leverages the resource to use the credentials to make API calls, right? So that's why it's declarative, because most of the configuration has already been defined within that resource, right? So that's why it defines the changes you want it to do. Okay, so that's the difference between imperative and declarative. And then we have comparisons between Terraform, Ansible, and Puppet. So Puppet is also an open source tool. It supports pretty much all cloud providers. This is a configuration management tool. So it's not like Terraform that it just provisions infrastructure and manages it. This can also configure your machine and update releases and packages. It's mutable, and the language is declarative. So Puppet 2 is declarative. You just basically gotta tell it what you want it to do. Puppet uses an agent. So Terraform doesn't use no agent. It just uses SSH to sorry, it uses the credentials you supply within the provider to connect an SSH to connect to the machines. But Puppet needs and require an agent to do that. Also, Puppet also needs a master configured, which is why it has an agent, of course. So you have the master, the server, where it controls the worker nodes, which are the agents. So whatever changes you make, it pushes it to master and distributes it between the worker nodes. The community is pretty large. Puppet has been around for a while, so the maturity too as well is high. This is a very, very complex tool. Honestly, a lot of enterprise don't use this tool. Some do and some don't, because it's very, very complex to understand. So yeah, that's Puppet. You have the Ansible. Ansible is also open source. It supports pretty much all cloud providers. This is a configuration management tool because it can push out releases and update packages within a server. It's also immutable. And this basically just means it's imperative. So you have to list the steps of what you would like Ansible to execute on the server. Ansible is agentless, so there are no agents required, and no master, of course, required. It's a huge community and has a medium maturity. It's been a while it's been around for a while too as well. It's definitely older than Terraform. I think Terraform is the least oldest. Terraform is also an open source, which you already went over. This is a typo here. It's not a configuration management tool. However, there are ways you can utilize Terraform as a configuration management tool. It's not recommended because you can, it just really depends on your infrastructure, right? Because there's a lot of scenarios where if you need to push out like a release, right? Majority of teams, they don't like to destroy the whole infrastructure and put out and push out a new release, right? They like to use Ansible to just configure that machine rather than destroying the whole infrastructure. For Terraform, if you need to update the release, you will need to destroy the whole infrastructure because it's not a configuration management tool. So that's the difference that's the major difference between Terraform and other configuration management tools like Ansible and Puppet. So yeah, that pretty much covers it. Before we go into the hands-on exercise, we can go into Q&A.
I have a question. So based on the what you showed us right now, can you go back to that slide? Okay, thank you. So literally Puppet and Terraform does the same thing, right? And I just want to ask, what are the plus and minuses between the both, aside from, because the only thing I can see aside from the maturity that the Puppet is like, because when I was trying to do some kind of job search yesterday, I saw a lot of company talking about Puppet, and I was wondering okay, what is this about? And some of them even put Puppet and Terraform in their wish list, because I call those long list wish list that they want you to have. So can you kind of based on your own experience industry wise, shed more light on that? Thank you.
Yeah, definitely. Thank you for asking that question. So with Puppet, like I said, a lot of enterprise, with my past project that I've been on, I haven't really worked with Puppet ever, to be honest. The only tools I can say I've worked with a lot is Terraform and Ansible. Ansible would be what you will come across mostly rather than Puppet. But the difference is, I would say, is Puppet, like I said, is written, I can't remember what Puppet is written in.
Puppet is written in Ruby.
Ruby, yeah, thank you. Yeah, it's written in Ruby.
a lot of Ruby coding. I've worked with Puppet. Now, the difference is this: Puppet, okay, requires you to install an agent on any server you want it to manage. Okay, if you want Puppet to manage the server, you have to install an agent inside. Now, what that agent will do is that the agent will be constantly listening for changes from the master, Puppet master. Okay, the Puppet master has all the configuration. So for example, I'll give you a scenario. For example, okay, in your Puppet master, you can have, it has what you have like a, what you call like a manifest, okay? Inside that manifest is all your configurations. For example, if you want your agent to have Java version 7, okay, and maybe Python 3, and maybe have Jenkins, so something like that, okay? Now, what your Puppet agent will do is that the Puppet agent will make sure that whatever configuration is in master is the same as what you have on the agent. So if the agent has Java 5, okay, it will make sure that it updates that Java 5 to Java 7 so that it matches what you have on the master. Okay, so if you want to make a change, like you want to upgrade from Java 7 to Java 10, okay, just in your Puppet master configuration file, just make that change from Java 7 to 10. Automatically, your agent will pick it up and update that package. So it's a good way to manage what you call to manage your servers. But there are lots of drawbacks because you have to install all the agents inside all your servers. And what if you have 1,000 servers? Okay, there are other ways to do that, but and you have to do a lot of scripting, okay, a lot of coding to support that base. And like you said, what you find mostly out there is there are primarily like 4 main tools in the market. Okay, there's Puppet, there's Ansible, there's Chef. Okay, now Terraform doesn't really fall into the management per se. It's more of configuration than management. Okay, so what you find mostly in the configuration management space, Ansible, Puppet, and Chef. Puppet and Chef, they are pretty much similar, but Ansible is much more straightforward. So a lot of companies are going into that. So the key thing there is this: if you just need to learn and master one configuration management tool. Okay, once you are good with one, they mostly just require you to know either any of them. If you see most job descriptions, they say, okay, we need somebody that either knows Ansible, Puppet, or Chef. Okay, and if they are using if they are heavy on maybe Puppet, they'll say, okay, if you have Puppet, is a plus. Okay, but hey, they are pretty much open because all these tools, they pretty much do the same thing. So if you know one, you likely, be able to use another one. Okay, but my very first project, okay, I came in with knowledge of Ansible, and what I met there was Puppet, so I had to learn Puppet on the job. Okay, leaving that project, the next project, I was now using Ansible. Okay, so I hope that clarifies something for you.
Yeah, it does. Thank you, Prince. It really does.
Thank you, Mr. Prince. That was definitely helpful. Any other questions? The floor is yours. We're about to go into the fun part. Okay, silence usually means golden. Let's go ahead and proceed so let me just bring that up here. Okay, so we're going to be going over the hands-on exercise today is installing Terraform on your local machine, as well as we're going to also deploy an EC2 server to Terraform. So No, this is just gonna be a blank EC2 server. It's not gonna have no configuration on it. It's just gonna be blank. Okay, so I'm not gonna go over this the installation of. I'm gonna go over it, but I'm not gonna actually do it because it's quite simple. So the Terraform installation, all you have to do is just navigate to this link. So for whatever platform you have, if you have a Mac, you install this on Mac. Then if you have a Windows, do we have Windows majority Windows users here?
Yes.
Or do we have any Mac
Yes,
users?
window, please.
Okay, no worries. Yeah, so just download this Windows file here to your local machine, and you should be all set. So just follow this instructions here. It's quite easy. You just have to unzip the Terraform package. Actually, I don't mind if one person would like to demonstrate before we go into deploying the EC2 instance. Or do you guys feel like you got it?
Let's have Wendy do that. Wendy?
Yay! I'm here. Okay.
Indeed, they have brought what you know how to eat best.
Why is it when
They just brought your
every
food.
time?
What you know how to eat best.
Oh,
Why is it
we have
Wendy every
only
time?
3 ladies. We have only 3 ladies in the midst of guys. At least now they should have some.
Please, they do partial. You do partial all the time. Now when they eat the cake.
Wendy na W, A day, B day.
Okay, well, I can't share because
Yeah. Can we have you, Wendy?
I'm gonna stop sharing now, so you can take over, Wendy.
Perfect.
And also I sent the agenda for today's session, so you can reference that link in the group chat.
Awesome.
I think you should just go to the blog, okay? And you're going to actually install Terraform on your local machine. So we are not doing anything on any AWS server yet.
Oh, is this the one? No.
No, this is not it. Check the group chats.
Yeah, I'm gonna get the second one. There were actually 2. Okay. All right, first of all, where's that link? Because I don't see the link. I opened the 2, well, that's from Tommy. Yeah, that's you. Tommy,
Actually,
these
I
are
sent
the
it
2
wrong.
you, yeah, those are not the ones you just opened.
Yeah, I'm sorry, I sent the wrong link.
Okay.
You can click the link. There's a reference link from that. See that? Please refer to the link for installing. Yes.
Okay. Yep, this is it.
Yes. So.
Okay, so I'm going to send this so that way every other person that's mad at Wendy can follow along. Okay, here we go. So download Terraform. Oh yeah. I think I saw that you used the 64.
Yeah, you can use
it'll
whichever.
probably be 64.
Okay. Come on. Why is this wasting my time? Okay. Hang on. Just let me be better prepared.
When you go to your download folders, okay, it's already downloaded.
Oh yeah, that's true.
Folder, the yellow
Yeah,
one.
yeah, I get you. I just want to bring the other guy in. Just bear with me a second. Okay. So
So did you already download the package? Try double clicking on downloads.
oh, there
There we go. Okay. Unzip that file, please. So right click on it. Yeah. You have to select it before you right click on it.
What am I selecting?
So the file itself, select on the file, exit out of this.
Okay.
When you just double click on the
Right-click
file to unzip it.
Okay. Double click again.
Yes.
So
Double click again.
the file has already been extracted. So follow the instructions on the left side.
Extract.
So first you need to extract that Terraform file, right?
So I'm clicking
So
on
if you go back
extract.
to downloads,
Okay.
and it's not extracted yet. So right click on it, extract all. Extract. Perfect. Okay. You see where it says the 2 arrows and download? It doesn't show the full thing, but if you can copy the whole, what's it called? The whole URL. So yeah.
Look at the arrow to your right, where there's like a refresh button. Yes, right there. Yeah. And then copy that.
Okay.
And then so let's go to the next screw up. So now we just have to set. So the first thing is we have to download the package. We already unzipped the Terraform file, and now we have to set Terraform as an environment variable, right? So navigate to your control panel.
On your search bar, just type in control panel in the search.
It's right here, babe.
Oh, okay.
Okay, and you can click on that. And you should see something that says advanced system settings somewhere on this. Or you can search for it too as well.
Well, I have just a system, but not advanced system settings.
Click on system. Did you click on system?
Mm-hmm.
Is this what it populated?
I believe so. Yeah, this is system here.
Okay, I think we're looking. So exit out of this. Let's do it.
When the go back, click on the back arrow, go to control panel. And now click where it say category on the right. No, right there, category. Click on that. Now click on large icons. Here we go.
Okay. So I guess I'm looking for advanced system settings.
System.
Okay, who has a good eyes here? Because I don't see it.
Try clicking on system now.
Oh, a system now. System. Oh, right here.
Yeah.
It brought me right back.
Pass. Looking for this.
Wait, do you want?
Oh, there we go.
Settings right here?
Right there. Mhm.
Okay.
Okay, so next, click on path. Click on system settings first, and then click on path.
System settings. I don't see any system settings.
Click on environment variables.
Okay.
And at the bottom, click on, yeah, so guys, this is probably different because she has a new model, a new Windows version. So that's why I'm having a little bit of issue here. Click on new here. No, that's not it. Cancel item. Click on new at the top is environment variables we're trying to do, yeah. There we go. Cancel it. Double click on path. There you go. New. And paste the path you, yeah.
Okay.
Enter and save it. Okay, you're done. So you can exit out of this and open the terminal and type in Terraform. It should be installed.
I should type in terminal.
So open your terminal and type in Terraform.
Okay. Oh, snap. Oh, man. Give me 2.5 seconds. I'm sorry. Can someone else take over? My son just woke up and it's, yeah, I'm so sorry. Oh, come on.
When you type in CMD, go to search, type in CMD.
I'm
She
so
said-
sorry. Can someone else take over?
She said to give her a second.
Yeah, if someone else can take over, because I know how this is gonna go. So I don't want to slow you.
Can give remote access. So
No, her son just woke up. She wants someone else to take over.
just remote access so that we don't start afresh. Because we are going back to installation again. That's what it means.
Oh. Yeah.
Okay,
How do
would someone like to take over, or we can just move forward?
you want me to give you remote access?
Oh yeah,
Remote
sure.
access
Actually,
will be
that would
better because we're almost done.
Okay, walking them through remote access.
She spoke English.
Tommy. Hello.
Hello.
Yeah, Tommy, this thing is being recorded. I'm thinking if you can just do it for us because of the people that's still gonna watch the video. If you can do it for us, we can just go from there. So we know it's gonna be straightforward.
Yes,
Right.
supported. That would be nice.
If you want a remote access into mine, I can grant you permission and just mute myself.
Because most of us are still gonna watch the video. So
Yeah, sure.
You're right,
Okay,
brother.
so guys, I already have Terraform installed on my computer. That's why I can show you guys how to do it. It's just a few steps. It's not anything that you should have issues with, to be honest.
Yeah, just show
So-
us on the left.
Wendy, give me control of your computer. I'll take it from there.
Okay, are you gonna request for control? Or how am I gonna give you?
Let me see.
Okay. Thank you.
Hey guys, what's going on? Are you done, Wendy?
Actually, let me just go ahead and show you the result, just to avoid.
That's what I'm saying.
When
If
did-
you can just pause to do it all over again, or if someone can do it for us, because most of us are still gonna watch the video.
one
And
second.
it need to be continuous. If it's not continuous, it might be difficult to understand.
Okay, so basically, she's already done with adding the path to the environment variables on her Windows machine. I'm using a Mac, so it's a little bit different, but whenever you're done entering the environment variables, all you have to do is just open a terminal, and this is my terminal here. So if you type in Terraform, you should see this after you've already added the file to the environment variable.
Sorry, hold on. Sorry to cut in. Tommy. Wendy, were you able to successfully configure this? Because I was lost at some point.
My son woke up. Okay, let me, I don't know. I can continue and then.
I think it's pretty straightforward. It's pretty easy. Tommy, do you have any other thing to show? Just this configuration, or do you have some more thing to? Do you have more time?
I was able to do it though, just FYI.
No, I wanted to show this as well as the EC2 instance. I just wanted to make sure that they're good with the Terraform installation before moving to the next one.
Okay, this one seems pretty simple. The Terraform installation for Windows is very straightforward.
All I just did was open Git bash and then typed in Terraform, and then it brought up the same information that you have.
You can work with Git bash. You can also work with your normal Windows command line. So yeah. So what's the bone of contention now? What are you people arguing or showing, or what? What's the issue?
We're okay now. We're okay.
Mr.
Okay,
Jide,
so-
what's the issue?
It's fine.
They're all good, Mr. Prince.
No issues, bro. Continue. No issues.
All right, carry
So,
go.
Carry go. I beg. Carry go.
do you want me to redo it again?
No. Just move on.
All right.
Okay.
We didn't know it's just to go to command line. We thought there are so many other
And
processes.
type Terraform now.
Yeah.
Bro, move on.
Okay,
move
so-
on. Move on.
She's since she already validated that she's able to she's installed Terraform successfully, we can go ahead and try deploying the EC2 instance. So I'm gonna open a new Windows here on my VS Code, and I'm gonna go to the lesson. So this lab also, the link to this lab is has been pasted to the group chat as well, so you can reference that. So here, I'm going to be deploying an AWS EC2 instance with Terraform. I said before, it's the easiest way to build infrastructure as code and automate the provisioning of deployment and also maintenance of resources. Okay, so we're going to go over that. You need to install Terraform within VS Code. So let me just go over that here. Okay, so it says open VS Code, navigate to file, preferences, extension, then search for install Terraform. So file. There you go, you navigate to code, preferences, Okay, so actually it seems like it's been changed. So now you navigate to, I think it should still be the same for Windows. This is actually just for Mac users. So go to code, preferences, extensions, and then here, just search for Terraform. So you install whatever Terraform. You can install the first 3. This is just for ensuring you have the correct syntax. So just install this. It should have install highlighted here in green. So you can just click on install and you should be good to go. Okay. And then moving along, we're gonna log into AWS console, and this is how we're gonna generate our security credentials. So once again, I'm gonna be showing you 2 ways on how to do this. The first way would be through using your root AWS console to generate your credentials. So your root is your actual account, right? So this is my AWS account here. If I go to my username, I go to security credentials, and guys, all this is listed in the steps here. So I go to my username, I go to my security credentials, and this page will populate here. Once it's populated, then you go to access keys, expand that. I already have an access key that exists here, but all you have to do is you won't have anything here if you haven't generated one. So this, you'll be able to click on this, and it's gonna basically generate a new access key for you, which should look like it should look like this. They should prompt you with. It should prompt you, so it's gonna prompt you with another window, which allows you to download the access key and the secret key. No, if you don't download this, whenever it prompts you that window, there's no other way you can get that credential. You have to delete the whole thing and start all over again. So make sure whenever you create new.
Yeah, sorry to cut it. Most of you that have done the lab on Ansible Tower, okay, we did the same steps. So it's pretty much, you're just repeating the same thing. So I'm sure you're not gonna have an issue. Just follow the directions and for you get your access key and your secret key.
Okay. Perfect. So yeah, you shouldn't have any issues with this. But now there's a different way of doing this, which is through an IAM. An IAM is basically where you manage like permissions, right? You manage permissions, you manage like users, you can limit their access, things like that. You can also provide like console access. You can provide programmatic access, which is going to be leveraged through using command lines. So the way to do that, and this is a secure way, right? This also is secure, don't get me wrong. It's just that you're exposing, if your access key or your secret key gets compromised, for instance, they would have access straight to the root user, which you don't want, right? That's why I usually recommend you generate a user and create that credentials, because then they would only have access to the user you're creating, not your root account. Okay, so the way to do that is basically you add user, you go to IAM. So let me start from scratch, sorry. Okay, so this is my AWS account. You go to services, you go to IAM, then you go to users. I already have one that exists here, but for this demo purposes, I'll create a new one. So go to add user. And then I'm just gonna name this Terraform user test. So this is what I was mentioning about like programmatic access or console access. This console access, of course, you would require a password to log in, which would be like this. And then the programmatic access would be where you can use things like the API, CLI, SDK to use those credentials to talk to AWS. Okay. So in this case, I really don't need console access. I mean, I'm only just trying to run Terraform locally, right? So I'm gonna set this to programmatic access, go to next permissions. So now this is where it gets interesting. This is where you give that user the permissions you want it to have. You can go to copy permissions from existing user, which I don't want to do. I'm gonna attach existing policy directly. So this is where you can limit users, not users, sorry. This is where you can limit permissions and the access of that user. So here, I really don't want to dive into this, but I mean, it's pretty self-explanatory. I mean, you just have to select whatever access you want to provide to that user. So for this purpose, I'm gonna select admin access because we're trying to create EC2 instance and have access to majority of the EC2 components required. So I'm gonna go ahead, next tags. This is if you want to tag that user. Tagging are usually recommended in a real life scenario. You have to tag every single resource that you create, as this is best practices and as well helps whoever, because you also have to note that you're not the only one working alone, right? So if you, let's say you work on an application server and you provisioned all of these resources, someone might be in charge of maintaining or tracking the budget of all those resources that have been spun up. So they have to make sure that yes, you're basically following the governance, right? So this, I usually recommend you start now and be familiar with it, you know, with tagging your resources as you create them, because it's definitely a good practice. And it's something that I recommend you should be by now be comfortable doing. So I'm just gonna name this name Terraform user, and go to next. And as you can see here, name, this is the username, programmatic access, permission, blah, blah, blah. This is my permissions here. Then I'm gonna create that user. So note, I mentioned it's gonna populate a window that allows you to download the access key and the secret key. So here, if I download this, it should have my credentials that I need. This is not the one I did. This is the one I did. I know it does provide a console link, but you're not going to be able to access it because I didn't provide no console access. This is only something you can run through leveraging the CLI. Okay, so that's how you basically generate a user for whatever you want to use this for. So you can generate a user for Terraform, specifically for Terraform. You can generate a user for your application specifically, and limit the permissions you want the application to have. So user, we're using this. This is also good information to also know, because we're using this for Terraform, right? Terraform requires credentials to talk to the API. But if this is an application, you can use things like roles, right? That would limit the access. Let's say your application or the server you're spinning up needs to, this is just extra, I'm throwing it in there. Let's say your server needs access to an S3 bucket, which is this service here that AWS provides. You can create a role, limit the access of the application just to talk to that S3 bucket and not to talk to anything else. Okay, so that's the benefits of this IAM. You can limit a lot of permissions, and also it stops a lot of developers from doing malicious things within AWS, right? because if you give a developer and admin access to everything, majority of the times they'll be doing some malicious activities. So you want to be mindful of that. That's how you generate the cert. But moving along, we're gonna go to create the file, the folder, to create our EC2 instance. So here it says go to File Explorer and create this folder. So I'm gonna go ahead and do that. Okay, so in this case, I'm just gonna name my EC2 demo. Okay. But you can name this Terraform Workspace, whatever you like, really. I recommend you follow the instructions, but you can name it whatever you like. It doesn't really matter. So after you've created that, then you go to VS Code, which I already have open here. And then you open that folder into VS Code. So go to File, Add Folder to Workspace. And I'm going to go to the directory I created that folder. So add this here. So as you can see, here already exists the EC2 demo folder. Then I have to create this file and copy the highlighted code. So let me create the main.tf, which consists of the provider and the AWS resource. And I created the wrong file. So here you just have to right click on the folder and then create. Then I'm just gonna paste that in here. So of course I need to change this information, the access key and the secret key, and I'm specifying my region. This can be changed to whatever region you like to provision that instance to. So let me go grab my credential here. Okay, so that looks good. I can go ahead and save this. Okay, so I'm gonna copy all those files first and then I'll explain that momentarily. Okay, seems like that's all we needed. Cool. Okay, so this is all you need to spin up an EC2 instance. Let's go over the first file. So the first file, we already went over this, the provider. We're talking to AWS, and we need the credentials, of course, to make API calls. We also need to specify the region. The AWS instance block, this, guys, don't worry about it. A lot of this templates are already provided to you on the internet, so this is not something you're gonna have to write. So be rest assured with that. But for the AWS instance, you just have to define the AMI, which I'm defining here, the instance type, T2 macro, the VPC security IDs. This is the security group that you would like to be attached to the EC2 instance you're spinning up, right? So I'm just referencing this file here, and I'll show you how I did that. On the tags here, I just want to tag my EC2 instance with this name. So that's why I'm giving it this name here. And then this is just an extra bonus that I threw in there. This is to output the current EC2 private IP that is currently spinning up after it's been created, as well as the public, as well as the name. So this is how you do that. This is Sterix here. So just to give you this is also available on the internet, but this is how you reference whatever resource you want. So it has to be the name of the resource, dot, whatever name, local name you've given it. So in this case, I gave it a local name of EC2 dot. This asterisk here is not required. It's only required if, let's say, I added counts and I'm spinning up more than one instance. If I'm spinning up more than one instance, then this would capture everything within this resource block, and output that at the end of the execution of this Terraform configuration file. So this is only required when there is more than one instance in the resource, defined in the resource block. So for now, I'm just gonna go ahead and delete this. And I'm just gonna go ahead and comment this out. So I don't need that. Because I'm only spinning up one.
Sorry, please, I have a question.
Yeah, go ahead.
So when you took off that the asterisk sign, the star sign, so let's assume you were doing 2. So you just put 2 there.
No, you have to put the asterisk sign.
So if you're doing 4, still the asterisk sign.
Yeah.
So
it
if you
captures whatever in here.
So you don't have to put the number of servers you're spinning, just put the asterisk sign.
Yeah, asterisk means everything.
Okay.
In the resource block, so you should be good. Once you put
Sorry, I want to let me add something. Okay, I had an interview a while back, and they asked me a question. Okay, how do you get the IP of the resource that you created? For example, you spin up an instance, and I was giving a whole bunch of questions, but watching your presentation, the very first 5 minutes, I think I got the answer. I think you can get it from this particular line, that line 22. Okay, that's where you get the IP address, right?
Mm-hmm.
Yeah. And where you mentioned during your presentation that you can, during the resource block, you could output the IP address to, you can actually output it to a file. Okay, I think that's so guys, my point is, please take this really, really serious, especially the very first slide presentation. That's an overview of everything. If you can, if you can get that part, all these other parts are pretty straightforward. You already have the template script, just explain it, put what you need there, and you're good to go. Okay, yeah, I just wanted to add that in. Okay, so carry on.
Yeah, definitely, and I definitely cosign with what he said. It's definitely important to know how to explain this, because they do like throw different kind of questions at you. They can throw it like in different ways. They just want you to answer the same question, right? So it's very, very imperative for you guys to know how to explain how to do things with Terraform. Terraform is very, very simple. Majority of the templates are already out there for you to utilize. It's just really how to explain it that a lot of people get shot on the feet at. So yeah, just be aware of that, and you guys should be good. So yeah, so this is basically outputting the private IP, the public IP, as well as the tags that I specified here. So this is only, asterisk is only for, once again, is only for whenever you define the count within the resource. You can also define it if the count is undefined. I mean, that is fine. It's for everything, right? So it doesn't really matter. So that is the main file. Let me go to the security.ts. So the security resource here is just creating the security group that is going to be attached to the instance, right? So here is the name of the resource, which is AWS_security group. This doesn't change. Once again, this never changes. This is the template. This is the name of the resource template, right? The only thing that changes is this. You can give it whatever name you want, right? So in this case, I gave it EC2_SG. And then for the name here, I just gave it EC2 dev SG, testing and low life cycle. So we're starting with dev environment. For description, just gave it EC2 SG. This is not required, but yeah. And then you define the ingress, and then you define the outbound. So this is the inbound, and this is the outbound. Let me give you some little tea that you guys, it might be helpful to you guys with all the CIDRs here. A lot of people confuse this. It can be tricky, right? So this is 22. I'm open the SSH port, which is port 22. If I do 10/8, that is only internal to the network, to whatever VPC I'm creating this EC2 instance on. So you're going to require some kind of VPN to log into it. That's only if that VPC is logged down to your cloud environment. If it's open to the internet, then of course you'll be able to log into it. But if it's 10/8, once again, it's always going to be internal to your network, and you're going to require some VPN to connect to it. The only way you'll be able to connect to it, if you spin up a box like this, just trying to think of it, is only if you, let's say you spin up like a Windows machine, right, with Terraform, and then you use that Windows machine as a jump box to log into this machine. Okay, but for this demo exercises, I'll recommend, for this demo, I'll recommend you just leave it at 0/0. That is going to be open to everything. Also, one thing you can also do for security purposes, if you don't want your instance to be open over the internet. So this is for whenever you guys are doing the project next week. This is good practices that I usually do on all of my instances. So that way I don't keep getting notification from AWS that you have a potential threat or something with your instance or something like that. You can change this CIDR to limit it to your own IP. And the way to do that is go to AWS, go to EC2, okay, so I'm just going to click on this here. Okay, so as you can see, I'm limiting this Jenkins server that I have to my IP, right? But here's how you get the IP. You can either even look it up on Google, what is my IP? And it will give you your IP, right? And you just type it in there, /32, right? But another way to get it is go to a security group, any existing security group in AWS, and go to add rule. You don't have to add this to the security group. You're just using this to get your current IP, right? So you go here and go to my IP, and there you go. So copy that. And you can paste it here. So what that does is you're telling, with this change you've made, you're basically saying no one can access my EC2 instance only if you're on my network, right? Only if you're on my IP. So only if they're within your your surroundings, that's the only way they'll be able to access this EC2 instance, basically. Okay, so that's the best way of security in your EC2 instance, so you don't keep getting those alerts. And then I'm just opening port 80 here, and then outbound is always open to everything. That is fine. This one is always open to everything, so this one can be left alone. And then I'm just tagging the security group, right? So I'm going to change this to my IP as well. And basically that's it. So let me go back to the instructions here.
This is
Okay,
Serge. I have a quick question. So are you saying that every time that you're on a different network, because you're going to have a different IP address, you have to remember to come back here and change the IP address?
No, so I'm saying that if you're testing, right, you're just testing, you're trying to create an EC2 instance within your environment and you're just trying to test it. If it's a real life scenario, of course, everything would always be 10/8. It's always going to be internal because obviously you don't want whatever application to be open to the internet. Whatever application you're going to be managing or you're going to be working on is going to be internal within your enterprise, right? But the reason why I'm showing you this approach is, let's say the project you have coming up, or let's say you want to spin up a Tomcat server, and you don't want that Tomcat server to be open to everyone all over the world, because you have people who can essentially like log into your instance, and you know, it depends if you're practicing, if you're following best practices, right? But the way to avoid all of that is to limit that specific server to your IP and test. So that way only you can SSH into that server, no one else. Make sense?
Yeah, I get it. Well, I think the question that he was asking is like every time, every time we instance that it gives us another different public.
Okay, what I'm saying here that we marble nowadays, right? Let's say that I take up my computer, I go to the library, and I connect to that library public network or whatever. I mean, any environment that is secure, or make my friend house, we're gonna do the project together, right? I'm gonna connect to his network, so the public the IP address is gonna change on my laptop.
Now, see, for this is a lab exercise, okay?
Okay.
For your lab exercise, you can leave it open to 000. But he's just telling you another way. He's showing you what's actually possible if you want to actually have maintained some form of layer of security. Okay. In real life, this your CEDAR block should be defined for you already. The organization will tell you, oh, what things you need to put in. Okay. And he's saying, okay, usually it should be 10.000, right, to be only within the network based on security best practice. Okay, so for the lab, okay, you can just leave it open. Okay, you don't need to bother by yourself about, okay, because in real life you're not going to be doing that, right? You're not going to be working on projects from one location to the other like that. Most of the time, most organizations, if you are working for them, they give you a laptop and then you connect through a VPN, so you are always within their network. Okay, even if you are connecting from a library, you be within their network through a VPN. Okay, so he's just showing you, the different aspects, different shades, what's possible and what's not. It's not actually this is what you should be doing. Did I throw more light on that?
Yes, Prince, but I understand that part. What I'm saying, but my question is generally just trying to know that because every time we log into our instance, it gives us a new IP address, public IP address. Is that the same with that IP address? Because is it going to be changed?
Now see, yeah, the instance IP address is different from your own IP address.
Okay.
This here represents your own IP address of your own computer. And this your own IP address is given to you by your internet service provider.
Okay.
The easy way to find out is through the way he showed you. If you go to AWS, or if you just go to my IP, what's my IP? Google my IP. Google will tell you what your IP address is, because everybody, as long as you're connected to a computer, you are connecting through an IP address. Okay, so your IP address is different from what the instance IP address. I also want to add, in real life scenario, you're not going to be having an instance that you stop at the IP will change. No, it's never going to, it will not change, it will be fixed, because your companies will probably be using an elastic IP, which is a permanent IP assigned to all your resources. So you won't have that problem, oh, my IP changed, let me go and change this configuration of that. Okay, we are doing all that because of it's a lab, we're all trying to learn. It's a very cheap way to learn. Did I answer you?
Yes.
Thank you, Mr. Prince. Any other questions?
No, I'm done. Thank you. I mean, that's all I.
Okay. Yeah, so basically that's it. You can specify your IP or just leave it as 0, open to everything. This really depends on you. And then I'm tagging my security group here, which is defined here. And that's pretty much it. So I can save my file here, and let me go back to the instructions. Okay, so it says open VS Code and open a terminal in VS Code, execute the following commands. So let's try that. We need to try with init, plan, and apply. So if you notice this plan, you see how it shows us this? Let's go ahead and try it here. Okay, so once you open the terminal, it should automatically just go into the current terminal you're working on. So you don't have to CD to anything. It should just prompt you to the current directory. However, sometimes it is defaulted to PowerShell, so you can navigate here and change it to Bash. Okay. So here it says I should run Terraform init. So I'm going to do Terraform init. As you can see, it's initializing the backend. And this is what I said, is downloading AWS plugin. So it's downloading all the required plugins that I needed to create this infrastructure. So it's done. As you can see, the next one is Terraform plan. Okay. So Terraform plan, once again, Terraform plan is going to show you an output of what is about to be created. So here, it's just showing you what is going to be created here. And it's also going to show you like a plan description here, which is you're adding two resources. So you're creating 2 resources. There are 0 changes to be made, and there's 0 resources to be destroyed. Okay. And the next one is Terraform apply. So as you can see before, there was no state file here that existed, right? I only had a main TF and security.tf. But once I executed Terraform apply, it generated this file, right? So don't forget, the Terraform state file is the blueprint of how you manage your infrastructure. Okay, so just to show you what it looks like, this is a metadata. Right, so it just shows you everything you're creating. You see, shows the ARN of the security group, the IP that I specified within my security, blah, blah, blah. So this, you don't really need to do anything with this. This can be stored locally and also can be stored remotely. So remotely is where it's stored in some kind of data storage, right? So Terraform allows you to use things like S3 bucket to store your state file. So that way you can basically update and manage your infrastructure as needed. So if
Can
you
you
have it
specify,
integrated
can you
with,
specify where, can you specify within your code the location where you want Terraform to like create or store the state file?
yes, you can. We're gonna be going over that too, that tomorrow too as well. But
Okay.
there's gonna be block here that is gonna specify that. But we're gonna
Okay.
go over that tomorrow.
Okay. All right, cool.
So basically, it seems like the Terraform apply has been executed. So as you can see, there are 2 resources that has been added. Here is the SG ID, and here is the instance ID. This is the output that I defined within my main.tf. So it's output in the private IP, the public IP, as well as the EC2 tag name. So let's go to AWS and just confirm that that instance has been provisioned. Here we go. So yeah, we have the instance tagged properly, and we also have the security group attached to the instance as expected. And yeah. Any questions?
Can you manually put a security group on Terraform on VS Code, or you have to go to the instance and do that?
The security group, can you, what do you mean?
Like if you want to add a new security group, like a part 80,000 or whatever, like do you do that here, or do you go to the instance that is created to do that?
Yeah, so you can do that. That's a good question. So you can do that 2 different ways, right? You can either go to the security group that you created with Terraform and make that change manually. That is not recommended, because whenever you apply another change with Terraform wouldn't notice the change that you have made. So it's going to delete whatever port you added manually. But if you like to add a new one with Terraform, all you can do is just go here, copy this, and create a new port, 8080, and then reapply that change. So now if I reapply this change, it's gonna update. Okay, so now let me see. Did I save that file? No, I didn't save that file, sorry. Okay, so I did a plan, and if you notice, the plan said there's 1 change detected, and that is the 8080 port I just added. So if I apply that change, it's just gonna update the current existing instance with the new port.
So whenever you do an apply, Terraform updates the current resource, or does it tear down and reprovision everything again?
It updates the resource. So it's using the state file. So that's why the state file is very important. It's using the state file to update the existing resource. It's not tearing down the existing resource. It's just updating it. Any other questions? So let me just verify here.
And my last question, on VS Code, you know, like started off say, like whenever you log into VS Code, like should best practice push and pull, like on the left bottom corner over there. Do you have to do this for Terraform, or does it do that?
Sorry, let me answer that, then Tom, you can add whatever. We are not working on a repo now, okay? We're not pushing and pulling to any repo. Okay, you push and pull and commit when you're working on repo. We are just editing a file. So VS Code is a tool you can use to write scripts. Okay, and that's what basically we are using it here to write Terraform scripts. Okay, and manage our Terraform process. Okay, VS Code can also integrate with your repository and perform your Git functions too. So in this case, we are not using it like that. Tommy, you can add anything.
Oh yes, I agree. We're running this locally, so we haven't even integrated like the version control with this using Git or anything like that. But to answer your question, we can use VS Code to push and pull requests from whatever repo we're connected to. You just have to make sure it's connected, so you can use, as you all should be aware, you can use the SSH approach or you can use the HTTPS approach, which is generating or supplying your credential, of course. But the SSH is a different approach. You have to, of course, configure that. But yeah, you can use VS Code for that too as well.
Okay, thank you very much.
I have a question, sir. Tommy.
Yes, sir.
Yeah, look at a very practical example. Like if you want to provision another set of EC2, why would Ansible destroy this existing one and like replace it? You know what I mean?
No, can you elaborate on that, please?
You already created an EC2 instance. Take for instance, now your manager gives you an instruction, say, I need another EC2 instance with all this configuration and using another name. I have observed over time that once you do Terraform apply, he's going to terminate this existing instance and replace it.
So the only way it does that is if you have, so for instance, if you have like a user data here.
Okay.
Right. This user data is, don't forget, the user data is like the same thing as remote exec, where you can invoke a script to a server, right? So if you have like a user data and then you update that user data, of course, Terraform won't know that it has to update the configuration. So the only thing for Terraform to do is to delete the entire infrastructure and reconfigure a new instance. So that's why I mentioned earlier that Terraform is not really a configuration management tool. It's more of like a provision tool. Now, if you want to make modifications to the instance, no, instance is different from updating packages or updating a release or pushing out a release on a server. You want to update anything related to the infrastructure. Terraform can do that because Terraform manages that infrastructure. Anything that has to do with the resources that are managed with Terraform, you can make whatever updates. But if it's a configuration, anything that pertains to a configuration, it would have to destroy the entire server and spin up a new one.
Now, can you do me a favor? Can you create another set of instance now? You have already running instance with another name.
Yes. I just actually destroyed that. So let me reapply that one more time.
Yeah. Okay. Guys, you guys should take this tool very seriously. It's a very common tool that you will always come across. Terraform. Okay, see creating. Okay, create another one. I needed another one.
Do you want, okay, if you want to create another one, is it going to be the same Is it gonna have the same, just a blank EC2
Just
instance, right?
just another name. Now you gave it a name. I need another name. Just give me another server with another name.
Oh, okay, okay, gotcha.
Hold on, let me see what we did. You have to T2 micro twice.
Yeah, so you wanted another instance, right, with a different name. So what I did was I copied this resource. Don't forget that you're gonna have to name the local name different. It can't be identical.
Yeah,
right?
sure.
So that's why I put like -test here.
Okay.
I'm creating the same exact instance. So it's an Ubuntu server, which is why I'm utilizing this same AMI.
Okay.
And I'm also utilizing this instance type because I'm trying to create another instance that is a T2 macro, sorry. And then I'm tagging it EC2-test.
Okay.
Okay. And then here, what I'm gonna do is I'm just gonna add another output that is gonna give me the output of that specific server, the new one I'm creating, right? So the name of the local I gave it here is -test. So I'm just gonna add -test here.
Okay.
Okay, so now let's try this. EC2, blah, blah, blah. Okay, so yeah, once again, the thing you have to note is you can name the output the same thing. So I have to name it something else. So I can do EC2, what should I give it? Add S here.
Okay.
I have a question. Please, for one instance, how many outputs should you have? Because there's a whole lot of output. I'm confused.
So don't be confused with the output. The output is what is being associated with that instance, right? So there's a lot of things in the backend that goes on whenever you're creating a EC2 instance. You're gonna need some things like the ARN, which it won't show you that information. You're gonna need things like associated public IP. Here, if you notice, it's just a plan. It hasn't even created anything yet. It's just showing what it's gonna add, right? So things like the subnets, things like the source destination check, blah blah blah, all those things are irrelevant. We don't need that information, right? Because that is added to the instance by default. Make sense?
Wow. Okay.
Yeah, apply. Let's refresh your browser. Let's see. Okay. Can you refresh your browser?
Okay, so now we have the added instance. Okay, there we go.
I think this was where I was making mistake. I think I was just changing the instance name. So whenever I do Terraform apply, it will terminate the existing instance and replace it with a new one. So, but what you did is like defining two blocks with different, I think I got it. Thank you so much. Okay.
No problem.
Yeah. All right, guys, I think you are done.
Yeah, I think that completes everything. Any other questions? Okay, if there are no questions, go ahead.
Yeah, so just I see what you did here. So if you have provision a server an EC2 instance already on it and you want to provision another one, you just have to, you don't have to edit the one you have there. You just have to add the block of the new ones you're provisioning on there and do Terraform apply. That way it doesn't delete the existing one, right?
Correct.
Mhm.
And you do all of this on the main, not on the what's it called, the state farm is not.
The state file doesn't, the state file doesn't get touched. The only thing you focus on is just anything that has to do with .tf.
Okay.
And also, so let's say, let me even give you a different scenario, right? Let's say the security group, you want a security group created for this one, and then you want another security group created for this one, this EC2 instance. You have to make another security group file and specify the ports, right? Change the local name. Change the local name to whatever you want to give it. And then in the second EC2 instance configuration, you just change the local name of the new SG configuration. And to capture the new one.
Okay. Sorry, I want to ask a question. Okay, I know some people had asked some questions as a little bit relative. Okay, now like the first thing you demonstrated, if you wanted to add a new security group, you just need to add another rule within your security resource block, right?
Mm-hmm.
You just need to add another rule and then it will just add that security group. For example, what if you want to change, for example, the instance type? Okay, you have like a T2 micro running, okay, and you want to change it to maybe like a T2 small. All right. Don't think an update would, to me, logically, I don't think it's gonna update like that. Like you are adding a security group. Will it tear down the whole instance and bring it back up?
Great question. So no, it's not going to tear up the instance. So as long as you're modifying anything within the resource, anything that is within this resource block would not tear down the server. It's only if you have like a user data, right? Like I mentioned, if you have like something like a user data, or you have like a remote exec, there's no way for Terraform to know those configuration has been updated. That's the only time that it would have to tear down the server. But if you're updating like things like instance type, VPC group IDs, AMI, tags, it's not gonna tear down the existing server, it's just gonna update it.
Awesome, this is really awesome. Mr. Kelly, what do you think?
Terraform is a very nice tool, so I think it's really interesting.
Now for your project, let me tell you what you guys are going to do with Terraform. You provision your entire environment with Terraform, okay? The environment is going to comprise of one dev server, one UAT server, QA server, one UAT server, and 2 production servers. And when I say environment, I mean Tomcat servers that will make up your environment. Okay, you're going to do everything with Terraform. So you have all the whole configuration within. You're not going to do any sudo apt-get. With a click of a button, Terraform init, Terraform apply, it will provision every single thing for you. That's what you're going to do in your project. So this is an awesome resource. If you get the first part, the presentation was awesome. Okay, and this is even much more. So get your hands dirty on this. Throughout this week, we are going to focus on only Terraform. If you have any issues, bring it up to the group. The way we tackled Docker Kubernetes is the same way we're going to tackle it. I don't want to see anything Docker, anything Kubernetes on our chat. That's the reason why Kelly is hanging around. If you have any issue with Docker Kubernetes, bring it forth after this class. Tommy, you're done now.
Let me quickly ask Tommy a question. I think I've read a little about Terraform, and I'm looking at this Terraform files that you have created, the main Terraform file and the security. Is the security file the same thing as like you declaring your variables? Is it more like a variable file?
No. So no, the variable file is a little bit different. The variable files, we're gonna cover that tomorrow too as well. It's just where you can, instead of like declaring things within your main.tf. So to give you an example, like the name, for instance, the tags here, instead of me declaring this in the main TF, I can pass like a variable here and say name equals to var dot name, right? And then I'll create a new file called variables.tf and declare that name tag, basically. So variables is just for declaring whatever you don't want to hard code within your main .tf, and then hard code it within like the variables. Make sense?
Thank you. Yes, yes. Thank you.
And another thing again is that you can have all these things in your main.tf, but you're going to have a very long main.tf. So I think this is a very good practice, okay, of like having like modularizing the whole thing. Easier for you to manage. Tell me, am I right?
Yes, very correct. All of those resources. I mean, it's not really. I can literally dump them in the main TF if I really wanted to, but I really don't recommend that, to be honest. It's just going to be a lot of code for you guys to read and be able to maintain, like he said. So just try to, like, separate them. If you have a security group you like to create, have a file for that. If you like an EC2 instance you like to create, have a file for that. If there's a database, have a file for that. It just keeps you organized.
That makes sense.
I have a question, please. And this is Dami. So if you're provisioning an EC2 instance that you're using different security group for, you have to create a security file for that particular EC2 instance if it's not what you already had before, right?
Yes. And you can manage this you can either just create one file for that security group where you manage everything in there, or if the security groups that you're creating is more than 3, or you have a lot of security groups you're creating, then I will probably just separate them into different files.
And
Thank you.
are they gonna be under one state file, or you have to create a different state file too with that?
For every workspace you're working on, right? The state file, you don't generate the state file yourself. The state file is generated automatically after you've ran the Terraform apply. The state file is going to consist of whatever you've provisioned or created in your directory. It's going to consist of the metadata. So think of it as information of your infrastructure, right? Now, the state file, you don't touch it. You don't do anything to it. You just let it be. And if you make any changes within your configuration file, which is the main TF, the security TF, or whatever file, it's going to automatically update the changes through that state file.
Let me add something to what he says, okay? Every main.tf will have a corresponding state file, okay? That is created from running that main.tf, okay? So you will never have a situation whereby you're having 2 or 3 main state file from one particular workspace. Okay, every workspace will have a main.tf, okay? And that main.tf is the main Terraform file that is actually referenced when you do your Terraform init and apply.
Okay, I got it.
Are we good? Are we good? Let's call this a wrap. Okay, guys, please, I want you guys to take this very seriously. I never had the opportunity to learn Terraform when learning DevOps. Never. Even Tommy did not, or Kelly. None of us did. The way Tommy is delivering this to you, this is world class. You can take this and dump it on any organization and it will run perfectly and smoothly. Okay. You look into much more details in this tomorrow, where he goes into more details, and you look at a professional way, how you integrate Terraform with Jenkins, and you see how everything works at the click of a button. He has a very beautiful pipeline that very, very unbeatable. That is, it can win award anywhere. Okay. You see the wonders Terraform will do tomorrow. But we are going to focus on Terraform trial this week. Okay. So take your time, watch this video, is important. Okay. Watch this video, follow the blog, follow it step by step. If you have issues, you can push it out. Okay. Tommy, are you done?
Yeah, thank you guys for having me. And like Mr. Prince said, if you guys have any questions, any blockers, reach out through the group. I'll be willing to help. And yeah, that's it. Thank you.
All right. So I think that we'll call it a wrap for today. We've really gone over the mile. It's not my intention. Always want to maintain it strictly 2 hours and we're done.
Prince, they have to, those guys that have issues.
Yes, I'm coming to that. Now, you guys are free to go. Now, if you have any issue with your Docker and Kubernetes, you can stick around, let Tommy help you get to the bottom of it. Hopefully, we should have everybody sorted out in this session, and then we are all going to focus on Terraform. Okay?
Okay.
No stress.
Zachary, I'll give you the...
Yeah, okay. No need to record this one. We just ask them.
I'm stopping the recording right now.
Just stop it. I think they should set up the environment and let's look at it one after the other.